In this demonstration, I'm going to make a program that uses the Sierpinski Sieve, or also called the chaos game. So we're going to make a program that follows these three rules. We're going to take 3 points in the plane, and we're going to have them form a triangle. And then we're going to start by selecting 1 point on the inside of that triangle. Then randomly, I'm going to select one of the 3 points. I'll call them A, B, and C. And what I'll do is I'll find the midpoint between my current point and that vertex. So I find that midpoint and I'm going to save it. And then I'm going to plot it. And what I'm going to do is repeat this process over and over and over again. So I'll find now a new random vertex and find the mean between my current point and that vertex and save that and then repeat that. And then at the end, going to see what the picture is that comes out from this process. So I'm going to do this as a live demonstration. I've not actually solved this before, so I'll work in real time and you'll be able to see my process and see mistakes I make and tests I make as I go about trying to solve this and trying to narrate it in the background. All right, so we need to, I'm starting with clearing everything out of my space, and that's where I'm going to begin. So we want to find 3 points that form a triangle. So let me define those here. I'll do this in as vectors. All right, so I'll call it point A is at 0, 0. And I'll say point B is going to be at, let's just say 0, 10. It doesn't really matter which points I use. And C, I'm going to say is, I'll put it at the midpoint here. Of these two. It doesn't have to be equilateral, but I guess I'll go with that. Oh, you know what? Actually, B, I'm going to make it a horizontal of 10 and a vertical of 0. And then C, I'll put in the middle, and I'll have it at a height of 7. So this will turn out to be, I guess, an isosceles triangle. But we'll see what it looks like. I can change these later. Okay, so these will define the vertices of the triangle. And what I'm going to do is I want to define a point on the inside. I could do this at random. It doesn't really matter, but since I'm going to repeat this, I'm going to make something called SAMPS. I'll start with 100 just so I can see how it's working without taking too long. And I'm going to keep track of all of my coordinates with a vector x, calling it zeros. And I want it to have SAMPS rows and 2 columns to it. All right, so I'll run this just to make sure everything looks the way I want. Okay, so X is going to keep track of every point that I am going to play or that I'm going to create using these rules. And what I'll do is my initial point, I'm going to say that X of 1, 2 is at I'll just say 1, 1 for now. I could make this random. I'll change this. It won't really make a difference in here. So that'll be my initial point is at 1, 1. Now, it doesn't like this. Oh, that's why. I want the entire first row to be 1, 1. Okay, now it works. All right, so if I scroll up to X, all right, it's starting at 1, 1. So that's my initial point. That is really going to be this step 2. So now I'm going to do the next part in a loop, because what I'm going to do is to get my next point, it's going to be the average between really my previous point and one of the vertices. All right, so in this case, I'll just pick an indexing variable k here. Now this is a point or a situation where I've already defined the initial point on X, or the first point on X. So I'm actually going to start this at 2 because the first row or the first point has already been defined. So I'm not going to start this at 1. I guess I can either say length of X, or I'll just use SAMPS because I'm going to run this initially for 100 repetitions to see what it looks like. And once I know it's working, I'll increase that. So what I'm going to do inside the loop is define now the second point, the third point, the fourth point, up to right now the 100th point. Okay, so I need to randomly select one of my 3 vertex points. So I have A, B, and C here. So different ways I can do this. I want to select at random, and I'll do this with equal probability A, B, or C. So one thing I could do is I could, I'll just call it Q. I'll use randi 3. Right, so remember, if I run this, it's going to give me the numbers 1, 2, or 3 at random. So with equal probability here. I'm using randi, random integer, because there's only 3 discrete choices to make. I can choose vertex A, B, or C. I don't need a continuous number, just one of those 3. Okay, so what I'll say is if I pick a 1, so if Q is equal to 1, I'm going to say that that is me picking vertex A. So what I want to do is find the midpoint for my next point. I want the midpoint between my previous point and A. So if I think about going into the loop, initially K is going to be 2. So my new point, I'm going to call K, X of K colon. All right, so like when K is 2, this is the second row, both columns. And that is going to equal, I want the midpoint, so I can use the mean of, in this case, I want A, and, you know what, I'll just do A plus K, X of K minus 1. And then I will divide that by 2. And that will be my average. I could have used mean, but this is probably a little bit easier here. For right now, I'll click that end, but there will be more things I want to do here. Okay, so let me just run this a little bit, make sure it's going to do what I want. I have A is at 0, 0, right? My X is at 1, 1. So let me just make sure this works. So I'll just, while I'm testing this, assign K is equal to 2. And I really just want to see, to make sure this does what I want. All right, so A plus K minus 1. Yeah, that makes sense because, again, it's 0, 0 plus 1, 1. So it should just be 1, 1. And then I want to divide that by 2, and I get 0.5, 0.5. Yeah, that makes sense. All right, so this is going to say, on my kth iteration, let's just say 2 at the moment, the second iteration is going to be the average between, in this case, vertex A and my previous point. All right, I now want to know here if I pick a 2, so if Q equals 2, I want to do the same thing, but now I have randomly chosen B to be that other vertex. And I could use either an else or an else if here, since there are only 3 discrete choices to be made. I'll just use another else if. So if I pick a 3 with that random number, then that's me choosing C as that third vertex. Okay, so now it's going to keep iterating. It's going to assign a value to the kth row of X, which is keeping track of which point I'm on. It's going to go to the top of the for loop. It's going to pick a new random number, which corresponds to me picking on the next iteration A, B, or C. And then for this new iteration, I'm going to take the previous coordinate, and I'm going to find the midpoint between it and then A, B, or C. And then this is going to keep going. All right, so I'm just going to run this just to make my X vector. Make sure that it filled out. All right, that all seems to make sense here. And now here it's telling me to plot the current position. I could do it on every iteration. That would be one option, using a hold. But it's actually going to be easier if I just do it at the end. So either one will work. I'd rather just do this at the end though. So I'm going to plot then my X vector. And I want to do this just as black dots at the moment. All right, so I'm running this. It looks like something went wrong because I have X values going from 0 to 100. So this does not look right. So let's see what went wrong here. All right, if Q is 1, if Q is 2, is Q of 3. All right, it's possible my initial point is actually not inside the triangle. I guess that's a possibility here. So let me just pick a point that I know will be. So 5, 1 will be. So let me just check if that's where I made the mistake. Nope. Okay, it looks like the Y values they go up to 10. That's probably too big. What could be going wrong here? Oh, okay, I think the way I'm using plot, it's for some reason not liking it this way. I'm going to take just the x values. So I'm going to take just the first column, every row first column, and then the y values. Usually this works. I'm not exactly sure why it's not at the moment. Let me see if that works. Okay, that works better. Typically it works if I use column vectors, maybe not, but that was the error. Okay, so now it's plotting the coordinates correctly. Let me make this a little bit bigger here. Right, so just set GSA, font size 14. Right, just the numbers are a little bit bigger. Okay, so we see here that things are looking decent. Again, A is at the origin, so that's one vertex. B is at this vertex at 10, 0. And then C is somewhere up here at 5, 0. And we see that all the points that we selected using this random process fall within that triangle. So that looks okay. And in this case, it should look a little bit different every time because of this random step at 31. But we see that all the points are definitely lying within this triangle. And here I could change this initial point. And again, every time I run this, it will be a little bit different, but it's following the steps. Okay, so I'm following the game here, the chaos game, by picking my point and then picking a random vertex and then picking the midpoint. So we see it's kind of forming a little bit of a shape here. It's definitely always within the confines of this triangle. But what's going to be interesting in this is what happens when we start to use more and more points, how it's going to fill out this shape. So at this point, we really have done the whole process here. We've included our random number, and we're doing something based on if that random number was a 1, 2, or 3. But now let's just explore what happens if I use more sample points. Okay, so that's pretty interesting here, is it's forming this nice little repeating, tessellating pattern. Again, this is all coming from this very simple rule of always picking the midpoint, and I'm always using a random vertex of A, B, or C as I go. Right, so we have this, this structure forming. And what happens here, let me use some more points. Give it some more and more definition as I go. So as I add more and more points, this might take a while if it's a million. But we see as we add more and more points here, yeah, we get some really nice definition in this tessellation or this fractal that is emerging, and we have all of this order coming, all of these little triangles within triangles within triangles. And actually, if we zoom in, hopefully the graphics card can handle this. If I zoom in on a triangle, we see that every triangle contains 3 of these triangles. Now, we're losing some definition here. Let me increase this a little bit more, make sure the computer doesn't crash by using just too many points. All right, and it ran. All right, so we're back to this main triangle here. And again, I just want to see if I can zoom in and see that this pattern keeps repeating itself as I zoom in. So let me just take this top triangle and zoom into it. And it looks, notice that we did zoom in, but every time I zoom in on the top triangle, it's just a kind of smaller version. I zoomed in again. It's just a smaller version of this same exact pattern. Now eventually it's going to break down because I don't have enough resolution as I go. So it's getting a little bit worse every time I zoom in. But keep taking the top of the 3 triangles. We see we can zoom in really, really far, and this structure still seems to remain here. I'll go back to the beginning. And there we are. All right, so that is the demonstration of this problem, the chaos game. And we see we make this really nice picture here, this repeating picture by following this simple rule. We've implemented a random choice between 3 distinct possibilities, vertex A, B, and C. We filled in our vector as we go. We saw that every point in this pattern was going to be reliant on the previous point in the pattern and a random choice between A, B, and C.